Jason Schaller is in the house, I hope. Here he comes. Okay, so Jason Schaller from Albuquerque Biopark. He's been managing the bugarium and rearing lab there and the butterfly pavilion at Albuquerque Biopark for nearly 8 years. Before that, he spent 15 years in Arizona putzing around the Sky Islands studying entomology at the University of Arizona and keeping and rearing a ridiculous number of different beetles, leps, arachnids, and other arthropods. Despite this being an amazing tenure at the biopark, he's soon embarking on a new journey as a science high school teacher. So we were talking, and here's a chance to reinvent himself. He could be Mr. Schaller, who's the nice teacher that flips the chair around and leans on the back, or he can be Mr. Schaller, who's a little stern, maybe. The students kind of fear him. So raise your hands. Schaller? Schaller. Oh, okay. So he's got his name now. The animal he would most like to see in the wild is Ryan Garrett. Be careful what you wish for. And then his talk is titled Big Beetle Bounty, How We Almost Perfected the Rearing of Goliaths and Other Giants. Welcome, Jason. You know how that works?
Yes,
Okay.
yes.
And
Hi.
Kim's doing time right there.
Cool, all right. Excellent. Can everybody hear me? All right, cool. So I had to shorten the title today to exclude that last part about other big beetles. While we've had some great successes with Hercules, Dynastes Hercules, and Megasoma elephas, I just didn't have a lot of time in this presentation, so I'm going to focus on Goliaths today. Goliath beetles have been one of my favorite animals on Earth since I was a kid. Actually, it was my older sister's favorite bug before it was mine, and I kind of stole it from her. All right, so I imagine most of us are familiar with Goliath beetles. I left out a lot of the life history on this presentation, but just a quick review. Goliath beetles are in the scarab family. They're in the flower beetle subfamily, Cetoniinae. They are amongst the largest insects on Earth, at least the males are when they're at their maximum size. They come from widespread in Africa, mainly in equatorial Africa. One of the species, the little one, Albos ignatus, goes down to South Africa. But there's 4 large species in Central Africa in the rainforests. Goliathus goliatus is the one we're talking about today. It's the most common and widespread and the most common in captivity right now. All right, so we'll start with just really briefly on the adult care. It's very typical for a big scarab. You want lots of climbing branches in the exhibit. So the picture here is of our display exhibit. We typically keep 5 large males together. That seems to be a good number. Over that, they tend to get a little restless with fighting each other, and it starts to reduce the lifespan. We basically use moist substrate like cocoa coir mixed with rotting wood chunks, high humidity, but also ample ventilation. So I like to have an irregular ground, of course, with a lot of big wood chunks to make sure they don't get stuck on their backs. And it's pretty straightforward. I'm sure a lot of us have kept a lot of big scarabs before, so nothing special in this stage. The substrate for breeding and rearing. We've found a lot of things that work, including 100% flake soil, 100% hardwood leaf mulch, and then any combination of the two. They're really not picky what they lay their eggs in as long as it's the right moisture and it's broken down enough. Usually we do about 6 inches deep of compacted substrate for egg laying with some buried rotting wood chunks. You can do a little deeper than that. We've had success in 5-gallon aquariums, 10-gallon aquariums. Probably the bigger, the more you'll get out of them. We tend to excavate our breeding containers after 5 to 6 weeks. That gives enough time for most of the eggs to hatch because they're a little sensitive in the egg stage. So after this point, you get mostly L1s with a few L2 larvae. And the egg setup is basically if you do excavate some eggs, you can put them in really compacted breeding substrate, poke little holes with your finger or a pen, put the egg in the hole, and then cover with just a piece of rotting wood or rotting leaf. And then you loosely bury the rest of it. They seem to be really sensitive if you just bury the eggs, but if you make that little hole with a cover on them, the hatch rate goes really high up, almost 100% sometimes. All right. So the base substrate for all rearing stages is we have had the best luck with 100% peat moss. A mix of half peat and half cocoa coir has worked as well, but do not rear them in any sort of rotting material. They don't seem to do well in rotting wood or flake soil or rotting leaf mulch. I have a hypothesis as to why that is I can discuss later. So here are the three different setups we have. L1s we'll put in these vials where the bottom inch is just compacted peat moss and then the top inch is the breeding substrate, which is your rotting leaf mulch or rotting wood or some combination. The L2s move up into a 32-ounce deli cup. Usually L1 is in that little vial for a few days to a week. They go very fast. And then the L2s are in this deli cup for about usually a month to a month and a half. And then again, we compact the bottom half of that deli cup with the peat moss. And again, really compacted. They like their peat moss, they like to tunnel in it and make a very kind of rigid, secure tunnel. So we don't want any loose substrate from, 7 years of, rearing this species. The compacted substrate seems to work really well for the larvae. They're very happy. They have their little tunnels. You can see them in their tunnels. And then we do just a typical lid on that with a lot of small poked holes in there to get that kind of Goldilocks ventilation, I like to call it. And then we leave about an inch of space from the lid to the substrate, because as that L2 larva grows and moves around, it's going to raise that dirt all the way to the lid, and then it'll get really snug and hard to feed if you fill it all the way to the top at first. All right, so L3s, we use these latching sterilite containers. There's a lot of brands that basically have these little latches and enough airflow gets in around the sides to where you don't need to actually add ventilation to these. And we found that the low ventilation makes the grubs happy. They like the substrate all the way to the ceiling, except for on the special feeding end, and just no extra holes poked. And this works in the, is that 13 minutes left? Cool. All right, and that seems to work in our humid, stagnant lab that's at 60% humidity, and the same thing works at room temperature in a dry office where there's less stagnant air. So basically, we set them up with almost all compacted peat moss, and then we have this feeding end where we basically excavate almost like a quadrant of the container and fill that with the rotting leaf mulch or rotting wood mix. And again, they're not living in that mix. It's only in the feeding end. And we found that it is important to have in there. When we were breeding these without any rotting leaf mulch, just feeding them their protein diet, they didn't get as big and they took longer. So there's possibly some micronutrients that they get from the rotting substrate. After all, it is the first thing they eat in life after they hatch from their eggs. So it does seem to be an important supplement throughout their lives. So yeah, we basically leave, again, space in that feeding end from the feeding end to the lid, because as that larva eats and grows, it's going to push that substrate up. Now, the temperature we found is quite a wide range. I've had them as low as 70 and they do fine, and up to 80 they do fine. Once they get a little warm, it slows them down a little bit. So 72, 77 has been the ideal temperature range. All right, again, here's a picture of just the typical containers we use. 10 quart seems to be a good size. Anything in that range. We tend to do a little smaller for female larvae since they don't get as big. You can also go larger for your male larvae. We've tried some really big tubs just as an experiment, and some of our biggest males came from those really big tubs. But we've had plenty of huge males in these just 10 quart tubs. All right, here's a little diagram of our setup. Again, compacted peat moss, our feeding end with the rotting wood or rotting leaf substrate, and then the food pellets are on top of the feeding end. All right, and then we'll go into larval care now. So as is well known amongst insect growers, the koi pellets are the best food source for Goliath, as it seems, in captivity. Here are two brands that I've used with a lot of success. There's another brand that I use. I couldn't remember the name of it off the top of my head and didn't have any pictures in my phone. But basically, any of the small, medium, round pellets, as long as they have similar ingredients to these two with a lot of wheat germ and fish meals and other stuff, they seem to work really well. One brand that does not work well is Tetra Koi Vibrants. They're these little rod-shaped orange food pellets. They're a little higher in protein, but I had just atrocious results with that. The females got stunted, never got above 30 grams. A lot of them slowly died. Males did a little better, but yeah, I've stopped using that brand. So it's good to be picky about the brand. To moisten pellets, we put them in basically a 32-ounce cup and do 1 cup of pellets and 1.25 cups of water. That seems to be the right ratio to moisten them. And then basically I kind of tumble those wet pellets back and forth a few times over the course of a half hour so they evenly moisten up, and then keep them in the refrigerator. And they're good for about 5 days. So every 5 days or so, you'll be making a new batch. And then feeding of the larva is daily. Let's see, I think, yes. So here's a picture of the cup with the moistening pellets. So yeah, well, feeding the larva daily seems to be the best thing. Again, if you miss 1 or 2 days here and there, it doesn't seem to have a huge effect. But as long as overall they're getting fed daily, that gets them growing fast and with very regular large sizes. So basically, the amount we feed is half a pellet of these medium koi pellets to an L1 larva, 4 pellets for an L2 larva, and then once they're L3, they're getting 30 pellets a day for the first 2 months, and then we reduce that amount to 10 pellets for female larvae, and then to 20 pellets for male larvae. All right, and then when it comes to changeouts, the best thing has been almost no changeouts. We do 2 changeouts for the entire larval duration, one from L1 to L2, and then one from L2 to L3. And basically, we just leave the L3 in that sterilite container doing the daily feeding and food removal, usually for about 4 to 5 months in the L3 stage before they enter the wandering stage. And so basically we have this setup where we just have a shelf full of containers. At the end of the day, someone goes through, removes old pellets very thoroughly. It's very important to find all the old pellets. For the first couple of months, there aren't really any. They eat them all. But then as they get into their 3rd month, you start seeing more leftover food, and that's when it becomes very important. So yeah, we basically feed daily. It's okay if you miss a day here and there. And then every 3 to 4 weeks, it's really helpful to remove a couple of handfuls of old dirt from the feeding end and just add a big handful of new rotting wood or rotting leaf substrate. And again, you can do it, every 3 to 4 weeks seems to be an ideal amount for that. And I think that helps remove some missed food pellets in that feeding end and just gives them fresh rotting stuff to feed on. And they will munch on that here and there. You'll notice some of it disappearing, some for more larvae than others. The pictures here is just one of my biggest larvae. This thing at its wandering phase, it came to the surface at 104 grams, so it had maxed out probably at 110 to 115 since they lose some weight. So yeah, that was really exciting. Unfortunately, this one was at a time where I hadn't really perfectly figured out pupation yet, and it ended up not making it, which was sad, but that happens. All right, so pupation has always been the hard part for Goliathus. They're very sensitive in this stage, but we've developed a method here that's been working pretty well for us. So I've found the best thing is to avoid wild dirts. Wild dirts, it's hard to know exactly what's in them. And after playing with a lot of wild dirt from around New Mexico, ended up finding that the thing that works best is this red art clay, which is a very basic ceramics clay. It's red, it's mostly aluminum oxide and iron oxide. Which are big components of rainforest soil that I've come to learn. And then the other is just all-purpose sand, usually pavestone sand or concrete sand from Home Depot or any retail store. Basically, we found 50 pounds of red art clay with about 13 to 15 pounds of sand is the ideal ratio. And it's very important to mix this up dry first, to get it really thoroughly mixed dry. Very important to wear a mask. That powdery clay stuff is not good to inhale. And then slowly add water to it. We found 1 to 1.25 gallons per 50-pound bag plus 13 to 15 pounds of sand is kind of an ideal moisture, but you do it slowly because this is a very tricky moisture ratio to get. They're very picky about this. A little too dry, they don't like it. A little too wet, they don't like it. And that because your sand and your clay are going to vary a little bit in the amount of residual moisture, it's hard to just put a discrete number on it. So it's really good to get a feel for that moisture. It should be kind of clumpy, but a little on the dry side. It's a really hard thing to perfectly describe. As I'm sure a lot of people know. When I had first started doing this, I was putting larvae in 5-gallon buckets, and then gradually reduced it down to this really perfect size. Males go into 5-quart Ace hardware buckets, paint buckets, and females in 2.5-quart Ace hardware paint buckets. They come with snap-on lids. We poke about 20 holes in the lids, and those holes are about 1/8 of an inch diameter drill bit. A screwdriver also works. They're pretty flimsy. And what we do is we basically fill the bottom with a slightly moister substrate. So we make our substrate, have it at that right moisture, and then when we put like the bottom compacted 2.5 inches in, we do like 5 spritzes with a hand sprayer, get it a little wetter, really, really, really compact it down towards like rock solid, and then fill it loosely all the way to the lid with the rest of the substrate that is at that original moisture. And basically, yeah, we set up all our dirt in these, and then we'll cover them with plastic or tape so they don't desiccate, and then they're ready for pupation. And basically, we'll mix a batch up, and I think 1 bag of clay with the sand added makes about, you could do, I think, I forgot the number, but you get a lot of pupation out of that amount, and it's pretty quick and easy to mix and have ready. So that's made our lives a lot easier versus collecting wild stuff and breaking up clumps by hand. Yeah, it got pretty laborious. All right, so wandering larvae, they're obvious. They end up on top of the soil, going around in circles. If you don't catch it on top, you will notice these tracks around the perimeter, and that's a good sign that the larva is ready to pupate. Moving it to the bucket's very simple. This is an old picture from when I was using bigger buckets, but you basically put the larvae on top, make sure there's enough room for it to close the lid. You can remove a little dirt, and then always good to tape that lid on with clear tape without covering holes, because they will break out. Here's something I'd come across before. Kirk, look away. Just kidding. But yeah, you catch this pretty quickly. And if you have everything right, the larvae tend to settle right away. I used to get excited when, oh, this larva took only 3 days to settle. Cool, we're doing really good here. And then after, many years of playing around with this, you realize, wow, 100% of the larvae settle right away when you get the right mix. And I have a lot of hypotheses to what's going on here. It's probably things like it's too dry, it's too moist. I've noticed low ventilation makes a difference. I've noticed high ventilation makes a difference. I had these in a kind of stagnant part of the lab once, tried running a little computer fan next to them, and that already dried it out and annoyed the larvae to the point where they would never settle. But just having them in a stagnant point without a fan also made them uneasy, and then putting them just somewhere where it was a less stagnant area worked. They're touchy. All right, I like to excavate the pupal cells after 5 to 6 weeks for males and 4 weeks for females. I found the best results when you don't flip the bucket. You just carefully use a spoon or your hands to dig to the bottom. They're usually in that compacted layer on the bottom, kind of half in the compacted layer, half in the loose layer. And then if you leave them in these buckets for too long, I've noticed, like, if you leave them for a couple of months to a few months, sometimes they'll get a little too dry towards the bottom, and then that larva will fail to pupate. If it gets too dry, it'll hang out dormant again and wait to be remoistened before it pupates. I've had some larvae take like 9 months to pupate. And remoistening these cells is very touchy. They are sensitive. All right. So yeah, gonna skip ahead here, kind of running low on time. Yes, so basically we can reuse the dirt, and I put it right back in the buckets and then just cover up the ventilation holes, remoistening it just a little bit to make up for any lost moisture, and then they're ready for the next grub later on. So the pupal storage I found that works best is this double encased setup where you have in the outer larger tub basically cocoa coir mixed with a lot of vermiculite, about half and half, and you make this really, really moist, like a lot moister than you would keep or grow anything in, but not quite a swamp where it's like, standing water, but a lot moister than what they would sit in. And then in the inner tubs, you have your pupal cells half buried in their original substrate at its original moisture. And basically, you just want to keep these very stable, temperature-wise, humidity-wise. And all you need to do in this setup is just mist that outer container substrate every couple of weeks, just checking in, make sure it's not drying out. And if that outer container moisture maintains well, then the inner containers maintain the perfect humidity. Ventilation, basically you want 24 holes roughly in the outer lid, and then you want holes in the sides of the inner tubs, but not on the tops, because if you're going into mist, any water getting on a pupal cell can kill it. It's crazy how sensitive they are. All right, I'm just about out of time here. So I'll just go through my takeaways. Goliaths are obviously just one of the coolest beetles on Earth. And when you get them to their large sizes, they're really amazing for education, for displays. Here's me again with, I think I had 14 huge males at once, which was really, really exciting. Never thought I'd ever get to see that. But yeah, they're such a versatile beetle for education, for displays. They're long-lived. They're just one of the best beetles you can have. And again, I want to give just special thanks to Steve and Barney. I know I sent an email out to you about collaborating, but I got really busy recently. And also just Jonathan Lai, many other breeders and my team at the biopark. Everyone's been very helpful with this project. Cool. And I guess I'll answer questions at the roundtable after this. But thank you, everybody.